All right, here's how Speed of Air Pistons work in under 90 seconds. So basically the dimples cause a disruption in the laminar boundary layer across the crown of the piston. So instead of a thick, static laminar boundary layer, it creates a very high turbulent kinetic energy. What that means is that inside that boundary layer, instead of the air not moving very much, it moves very rapidly in like little tornadoes. That provides better micro mixing at the surface of the piston, which gives us a little better combustion efficiency. Additionally, it makes heat transfer out of the piston very, very efficient. So as a fluid flows over the dimples, the leeward side of the dimple or the back side, the direction of the air across the dimple, becomes a very high impingement area and a very high heat transfer region. And so we're able to dissipate heat much more efficiently, much more quickly. Better combustion is going to give us better fuel economy, better power and torque, and it's going to reduce criteria emissions, particularly particulate matter. So we do use coatings, and our coatings have not only a thermal barrier component to them, but they also have a high thermal reflectivity component. So we're actually trying to reflect that thermal energy back into the turbo before it leaves the combustion chamber, but we're able to dissipate the heat quite quickly. The NOx reductions are directly related to heat and EGTs. So if we burn the fuel more efficiently inside the combustion chamber, that's less fuel still burning as it exits the exhaust port. Secondly, the dimples also become a very efficient thermal transfer modal, so we further reduce the heat going out of the exhaust port.